the reason why we go high pH on soils is the same way we do high pH or low pH for water holding capacity in products, right? We want to put charges on the soil, and that charges makes it more likely to get up and dissolve into water. So your caustics do it as well too. And the reason why I'm kind of mentioning that is because we can talk through all the effects, but several of the different cleaners will have multiple effects associated with them. So we can dissolve, liquefy, hydrolyze, disperse, or emulsify, depending. But that's very technical. Usually, and then here's my pitch: whoever you are working with for your chemical provider, they should have a pretty good technical background, and they should be able to, suggest the products that you need for the soil and the surfaces you want. So.
Welcome to MeatsPad, a platform dedicated to sharing breakthrough knowledge that is accessible to the meats industry. These discussions help foster and improve communication and knowledge dissemination within the meat science community. This podcast is brought to you by the U.S. Meat Export Federation, the National Provisioner, UltraSource, the new standard for innovation. Dry Age Pro makes dry aging in-house flexible, safe, and affordable.
Viscofan, the casing company.
Hello, meat folks. Welcome back to the MeatsPad podcast. This week, we continue these conversations with meat leaders, and today we have a very good professional. He's going to talk about sanitation. But before we introduce him to you, how are you, Dr. Bass, today?
Francisco, the guest we have today is a blast from the past, from my past anyway, not necessarily from the listener's past, or maybe it is. But Dr. Jeremy Adler and I were in grad school together at Colorado State a few years back. He was more on the food safety. I was on the food quality and production side, meat quality and production, and Jeremy was doing a lot more on the how do we keep it safe? How do we improve that process? And what was cool about those times, and for anybody that's in grad school or has any grad school background, knows that cross collaboration during those times really is super beneficial for us as we're developing, as we're growing, as we're learning, but then also later on. And I'm going to tell you, Jeremy Adler is going to be one of those that many people need to know because of his production experience, his industry experience, but especially his food safety sanitation experience. And so without further ado, of course, Jeremy Adler, tell us a little bit about yourself and about Ecolab, which is the company that you represent.
Thanks, Phil. That's pretty big shoes to fill. Phil.
Yeah.
But no, it'll be great. I really enjoyed the graduate school that we had together, and our cohort has done really well, actually. It's been kind of nice to follow everyone. And luckily, there's been several of them, and we can reminisce later, that's been a lot more successful than both you and I. But we've had a real good cohort. And I did try to jump over. My advisor was Dr. John Sophos, but I always try to jump over on your guys' side of the things and join you in the plants and help learn how to break carcasses and learn, the in-plant value that I could bring through food safety. So that was a great thing. Currently, I work for Ecolab. My official corporate title would be Senior Research Development Engineering Program Leader, but I'm mainly focused on food safety and how to put a food safety spin in our product innovation pipeline, the new products that we bring to market that increase food safety. And then after that is supplying the technical documentation so these products can be successfully applied in plant, whether we're talking cleaners and sanitizers, or even antimicrobials that you can apply directly onto food tissue. So there I am in a nutshell.
Yeah, well, and you're being very modest, of course. I mean, the background that you do bring and the experience, the in-plant experience that you've had, you've been in this in a position in food safety sanitation for a number of years now. And for our listeners that are out there, a lot of our medium to small processors, but even the big ones that are out listening, sometimes we need to be reminded of just the basics. And so for those who have been following MeatsPad for a number of weeks, months, we've hit on a number of basics. We've hit basics of meat processing, of slaughterhouse design, of things like that. And sometimes we need to be reminded of that. And so, Jeremy, could you just kind of give the group, the listeners right now, kind of just the basics of when you're putting together a food safety sanitation program, what are some of the things that folks need to be considering?
Yeah, I mean, a great title for this project could be, or for this podcast could be, nothing's changed, but yet everything's changed, right? In the world of sanitation, we still apply a cleaner, we foam it on, we scrub a little bit, we rinse it off when we start production again. But, there has been some changes too that we'll probably touch on a little bit. But, to start it all off, the mega reg, which we call the HACCP, the preventative controls, the HACCP reg in the mid 90s, kind of stated out and said that plants, you have to put together sanitation standard operating programs. You have to have a sanitation program in your plant. And we just kind of go from there, so this is mainly meat. So we have a pretty, we're dealing with proteins. If we brine a little bit, we got some minerals, but the major soil is what we call it that you want to remove from surfaces is going to be proteins. And in general, I'm guessing probably about 95% of the people listening to this podcast are going to apply some sort of caustic, a sodium hydroxide, and then they'll chlorinate it to get that oxidative power off on it to break up that protein so we can get it off the surfaces and into the drain. But I mean, that's pretty much what we do. We just find soils on surfaces, try to remove them with different chemistries. Those chemistries try to remove it as easily as possible, or we can talk in terms of time. We need to reduce time to increase production time. That's always seems to be a big hot topic in most plants is, clean and sanitation time is also time taken away from production. And then also resources too. We're starting to make a big resource play as far as water and energy as well too. So these are all factors that you can consider when developing your clean and sanitation program. But ultimately, bare bones, right? We got our soil, it's protein. We need to figure out what surfaces we have. Most likely it's stainless steel. It could be some, plastics as far as belting and like your cutting boards. But so as long as we know the soil and as long as we know the surface, we can come up with a cleaner that's going to remove that soil from the surface.
Yeah, no, and this is great. I think there's a lot of paths that we can go down, but just going back to the basics, could you please tell us some of the most popular cleaning supplies? Yeah, we call it supplies. So we got chlorine. I mean, you mentioned a few of them, but we can maybe talk about the importance of those and maybe where should we apply it and when. I think that's pretty basic, but I think we can start from there.
Yeah, exactly. And usually when I'm talking about this kind of stuff, I mentioned it before, we figure out what our soil type is, and we have 4 major soil types. The first one that we're probably going to be most interested to this podcast is going to be your proteins. And then you have fats and oils, and then you have carbohydrates and minerals. So those are going to be your 4 major soil types that we're going to identify within your process. And then there's several ways to remove them from surfaces. The first is you can dissolve them, and that's the easiest. If say you have some sugar and dissolves it in water, you can get it into the water and get it to the drain. So the whole idea is water is basically our vehicle. We want to get the soils up into the water, and then we want to get that water to the drain as fast and expediently as possible. If not, if we get pooling, then we start talking about, as being contamination source throughout the plant. But just to take just come back to the original question, it's all how can we get it into water? So we can either dissolve it in the water. We can also use temperature to liquefy it, such as, fats. We want to use probably about under 140 degrees water, well, not 140 degrees Fahrenheit water. That will help liquefy most of the fat that we have, whether we're talking about beef, poultry, or pork fat. Right, with beef having the highest temperature for melting, and then and then chicken and poultry after that, but about 140 or less. And then there's also a worker safety issue that we have to work in there too, but at about 140 is the limit. And that's probably a key number to know, because 140 and above, we could start baking on proteins onto surfaces. And then also too, there's a safety consideration, because if we are using a chlorinated caustic cleaner, if we're at 140 degrees and above, we might start flashing off that chlorine, and we could start talking about employer safety. employer and employee safety as far as creating, gaseous chlorine in the plant, which is noxious and potentially fatal. So that 140 and below is usually what we try to stick for temperature when we talk about liquefying. And then another thing is we got protein. We can just chop it up into different pieces, and the way we do that chemically is to hydrolyze it. And the way we can hydrolyze it is we can go to our pH extremes, right? We can go to a high pH with our alkaline cleaners, or we can go to a low pH with our acidic cleaners. And then also enzymes will allow us to hydrolyze that soil. And then, of course, too, then if we can't get it, we can call it dispersion. And dispersion chemistry is just something to get it off the surface, up into the soil, up into the water, and then we just want to carry it to the drain. And when we talk about dispersion chemistry, that's when we really start talking about our hydrogen peroxides, which can also be an oxidizer, or a peroxyacetic acids as well too, because these penetrate into soils and basically just pop them up off the surface into the water, and then we try to get the water to the drain. And then finally, we always talk about emulsifying. When we start talking about putting surfactants in with our caustic cleaner, we can emulsify fats, so we can bring those fats up into the water, because fats don't like to be water, right? They're not water loving, but somehow we got to get them into the water. So we put a chemical that has two charges on it, which is a surfactant. So the surfactant binds the fat particle, and then that also the other end of the surfactant allows that fat particle to get suspended into water. So those are 5 kind of effects. So we just kind of, again, soil type, what kind of effect we want to use, and then we just pick the chemistry that we want to use based on that. If we dissolve, it depends on the soil as well too. You can dissolve minerals by an acid. You can dissolve sugars with a water. If you want to hydrolyze, you can hydrolyze protein with enzymatic cleaner. You can hydrolyze it with your caustic cleaners. You can also disperse it, right? It depends on who you talk to from a chemical perspective, right? The reason why we go high pH on soils is the same way we do high pH or low pH for water holding capacity in products, right? We want to put charges on the soil, and that charges makes it more likely to get up and dissolve into water. So your caustics do it as well too. And the reason why I'm kind of mentioning that is because we can talk through all the effects, but several of the different cleaners will have multiple effects associated with them. So we can dissolve, liquefy, hydrolyze, disperse, or emulsify, depending. But that's very technical. Usually, and then here's my pitch: whoever you are working with for your chemical provider, they should have a pretty good technical background, and they should be able to, suggest the products that you need for the soil and the surfaces you want. So this is good information to know, but ultimately you should have some support as well too from your chemical supplier that'll really help pinpoint, because they know their products the best, and they'll help pinpoint the soil type and the effect, and also the chemistry that you needed for your project as well. So that's kind of a rundown of the different kind of cleaning options out there.
This, Jeremy, this is a great example of how us production guys needed to go back down the hall toward the food safety guys and learn a lot more, because I've been taking copious amounts of notes. This is really, really good information. And you hit it right on the head and regardless of the topic, right? Whoever your consultation expert is, make sure that you're visiting with them to figure out what is the best approach for the business. Okay. In this case, we're talking about cleaning agents and chemical agents that are going to help us dissolve or emulsify or disperse or whatever. Talk with your representatives to design the right system for you. Now, something that also I'd like you to touch on a little bit, because you've talked about the water part, and I'm not going to have anybody raise hands, listeners or otherwise, but how many folks out there have just grabbed the hot water hose and kind of just pushed the meat across the table, across the floor towards the drain, and then let's call it a day, clean enough, right?
Right.
Or splash some magic solution, whatever that is, put it on the table, rinse it off, and away we go.
Yep.
Can you talk a little bit about the importance of mechanical action, mechanical disturbing? And I'm talking about scrubbing, right? I'm talking about elbow grease at this point. How important is that, and why, if it is important, why is that so important?
Yep, exactly. So the first thing, like on all my talks, the one of the first slides you put up is the perfect solution doesn't exist, right? I wish I had a cleaner that I could come in and just spray the plant, walk away, rinse it off, and then we're clean and ready to start, right? So it leads nicely into what I usually try to show is the 4 factors of cleaning. It's going to be chemistry, right? We talked a little bit about chemistry, and then temperature. We talked a little about temperature. Time. Time is very important too. Do we have enough, a time of exposure to the chemistry for it to work? And then finally, Phil, the 4th one, which you just brought up, because we did, although we did not trade notes, you were prophetic. And you come up with mechanical force, right?
It's only because I've been in the business for a little while now.
Right. And those 4 factors, I always think of it as holistic, right? That's your whole cleaning program right there, and they all work together. And if you have to reduce one of the other 3 has to make up for it. So if you don't have the time to clean, what do we need to do? We need to increase temperature, or we need to increase chemistry, or we need to increase the mechanical force, right? We don't have the labor to implement the mechanical force. Well, then we need to either increase the chemistry concentration and exposure time, or even temperature to that problem. So all 4 of those factors I previously recommended need to work together in order to have a holistic cleaning program. Specifically for mechanical action, when we talk cleaning in the meat industry, in the meat space, we're basically talking a manual clean, or what we call COP, clean out of place cleaning, right? It's real easy. I say it's more simple in dairies because everything's in tubes, and you just put the cleaner in a big tank and you push it through at the right volume. You get your mechanical action through your vortex flow.
And that's clean in place.
Yeah, that's clean in place, correct.
Yep.
So what we need to do, since we're talking environmental cleaning and surface cleaning, is mechanical action really is highly necessary. It's very time consuming, but it's one of the few ways that we can get into the nooks and crannies, and we can really address the soils on surfaces without high pressure water, right? That's the other thing we need to touch on. You mentioned water. High pressure water, while it does very good at removing soil from the point of contact, all it does is it just disperses it throughout the lab. So the current thinking is we don't recommend high pressure water. If we do, most plants that do it correctly will have high pressure water after the first rinse, and then they'll just turn off their pressurized water. Because if you think about it, that soil just goes to other parts in the plant, and you can take soil from a cutting board and put it on the ceiling. You can take, more importantly, you can take soil with high pressurized water from a drainer on the floor and put it right onto a food contact surface. So that's why we really don't like high pressure water. So without that, and you've seen it in plants too, right? They use the water broom, right? You don't want to get the squeegee out. You have this piece of trash, and you just see guys following it across the floor in the production area, just chasing it with water. And that's just a waste of water as well too. So without that, we need some sort of mechanical action. We need scrubs, we need brushes, and those need to be specified for a specific area. We don't, and why I'm saying that is because we don't want our brushes for drains, and we don't want to go over and clean food contact surfaces with them. We want them dedicated to each of the specific areas. And we could lead nicely into a nice discussion about sanitary design that we may or may not get to, but ultimately what we have to clean is what we have to clean. It might not be optimally designed, but hey, nothing really is ever. So we have to take what's in the plant and we have to clean it. And so with our eyes, we can use brushes, and we can get the places that are hard to access through cleaning, through the cleaning chemistry. And that's usually some of the ways that we can access the soil from surfaces. And that also might include breaking down of, belts. We'll pull belts off of off of the line, and we'll clean those separately, or we might have to disassemble a piece of equipment just to make sure that we can get to each part to where they're cleanable and accessible. And that's just done all manually. So talk about mechanical action. It's just like you said, elbow grease, or usually in the industry we joke it's EG 5000, right? Elbow grease 5000. It's a product we recommend.
I love it.
Now, I have like a couple questions like as a follow up, and I think the exposure, the time that you brought up, it's super important. Sometimes we don't dedicate the time. It's just, hey, just add the sanitizer and just rinse it off and we're good to go. But each sanitizer has its own exposure time, so that's important. But we can also discuss more about the frequency of the sanitation program. I had this conversation with folks saying, hey, do we have to sanitize every production lot or after every day of production? I know there's out there some companies that do. I mean, that really depends on the validation of their sanitation program. Could you please tell us about how often do we have to, or maybe take it back. The importance of the frequency of the sanitation program. Is it every day? Is it every hour? I think that can open up a whole conversation about the frequency.
Yep. So depending on your viewpoint, I guess I'll play my cards here. Luckily for the USDA inspected plants, right? We're not talking FDA. USDA inspected plants, it's pretty much daily sanitation. And that's what we need to do. Now you can petition for what they call less than daily sanitation, but you have to petition for that, and you have to show data that you're not causing insanitary conditions by cleaning less than daily. And you usually see that in poultry plants that want to extend the use of their water and chiller. But for the most part, right, there's always the oddball, but for the most part, we're talking daily cleaning in meat and USDA inspected plants. So that's pretty straightforward and simple. You can go less. It's all up to you, and we could have a whole nother podcast on environmental monitoring program. But I would have to say probably the reason why you would want to clean during the day would either be you have collected micro data in your plant that shows that the micro counts are getting pretty high, and you have data to, we're talking about frequency and validating the frequency of your cleaning program. And you have data to support the fact that maybe you should clean, but I don't usually see that. Usually I see cleaning from an allergen perspective, right? So again, we could have another tangent on allergens. There's a million tangents we can go on when we're talking cleaning and sanitation. But most of the time you get daily cleaning when you have a switch over product lines, when you're starting to talk about allergens. Again, for the most part, we're talking USDA inspected meat and poultry plants. The only thing where allergens is going to be of an issue is when we talk about specific ingredients put into that product, soy, wheat, things along those lines. So not as big of an issue with us on the USDA side of things, but it's still. So increased frequency would probably be the main driver right now. And that would be dictated by your allergen control program. Or very rarely, say you collect enough environmental data that shows that your process just gets too dirty during the day from a micro standpoint and you have to clean. But that being said, most plants will do an intermittent cleaning during breaks, during production breaks, during employee breaks, during lunch breaks, where they'll just go through and just grossly remove the soils off the tables, or they'll just apply some sanitizer during breaks just to kind of knock down the bacteria as well too.
Well, and you bring up a really good point about we do have processors that are using a variety of different ingredients, and maybe they are one of the listed major allergens. The soy, like you've mentioned, wheat, milk, proteins are often going to be one that we need to think about. And for the listeners out there, I mean, if you are using these different ingredients, we go to the extent of nitrates and nitrites, and just think of the product flow. And if you have stuff that is going to incorporate additional ingredients that either need to be specifically labeled or of concern for health issues, then you do those later in the day. If you have the lower amount ingredient products, do those earlier in the day, and just consider that as you're going through, so that you don't have that crossover and maybe the necessity to have that additional cleaning in interventions in between.
No, that's very valid. And process order is definitely a way of controlling allergens.
And super simple, right? As long as you can plan the day well enough, super simple. Ultimately, what I'm hearing is we got to find balance for the right program for cleaning and sanitation, and find a balance in the chemistry, the temperature, the time, and the mechanical action that is going to be necessary for properly cleaning the room, the meat blocks, the conveyors, etc. Added chemical is going to increase cost. I mean, we have to keep that in mind. And anything that goes onto the table has to go down the drain and be processed later. Temperature is added cost in energy, and something that's a big. It's a big thought in a lot of people's minds, is how can we conserve energy for these processing plants so that they're sustainable, we're environmentally friendly, etc. Maybe it is more of that dwell time with the chemical action on there, but of course we don't want it to necessarily dry unless you do have some product that you want to dry on the table. I can't imagine you do, but maybe, you're the you're the senior researcher out there, and so maybe you have something cool out there that we don't know about. A powder, a magic powder.
There you go.
We can sprinkle on. And let's not forget the EG 5000, as you just mentioned, the elbow grease.
Yep.
Labor is expensive, but it's extremely effective, and so we just got to find that balance. Right?
No, yeah, you're right. It's balance, and it's always, in a way, it's difficult to come on and do podcasts like this because you have to talk at such a high level.
Yeah.
Because each plant, each process, each product, they're all different. And so it's very difficult to give specifics for a specific process when you're talking to large audiences such as this. But I think balance is the key word there, right? Let's identify your process. Let's see, and part of that is figure out what your limitations are. What are your limitations as a processor? Is it time? Is it temperature? Or does your boiler not handle enough water to get a full cleaning shift out? Is it employees? Is it the design of the plant? Is it design of your equipment, right? Let's figure out your limitations, because as soon as we identify our limitations, right, we can develop procedures to make them, we can develop procedures to address them, and then ultimately give you a clean plant. And that's what we're going for, right? There's been too many of these plants that have been built, 40s, 50s, 60s, and they add on and they add on and they add on. And each one of them is unique, and each one of them has their own challenges. But fortunately right now, we can develop procedures to address all of them, and then limit the food safety issues that they might provide based on those issues defined.
So this is awesome. I think going back to Dr. Bass' first question on the basics sanitation, and as you said, there's a lot of tangents that we can go, but I think that just opens up the room for more conversations down the road. And I'm sure how's COVID changed the way you do the sanitation in the meat industry? And we can think about in the beginning, we didn't know if COVID was transmitted through meat. So there's a bunch of research going on right now to learn more, understand more about this virus. So could you please elaborate more on that? Your role, Ecolab as a company to tackle these issues that we saw last year.
All right, very interesting time. Specifically, like I said, I'm not going to go into Ecolab much, but I'll kind of intertwine it. But it opened up some challenges, and I think the industry recovered nicely, or addressed them nicely, right? We had the OSHA guidance come out for meat and poultry processors, and then we implemented those nicely. But the biggest overarching thing that I think that was new, that kind of touched, that was brought forth, was this idea of disinfecting plants, right? Because we start talking about before, we're always worried about the bacteria, right? The E. coli 0157H7s or the STECs. or the salmonellas or the campylobacters or the listeria. But now we had this virus come on board, and at the time we didn't know if it was a foodborne pathogen, right? Luckily now the data supports that it isn't. But yeah, I still think we developed some procedures as far as disinfecting the plant process itself, right, in the processing room, and also the auxiliary areas. And we talk about disinfecting. When we disinfect, we're able to use a higher concentration of chemistries. We were able to use different chemistries. And we're able to leave them on for a longer period of time, so we get greater reductions, both from a viral standpoint, but what that also does too is it gives us a bigger reductions from a bacterial standpoint. If you think about it, go back to sanitizers, we're very limited in our sanitizer choice just because of how they are regulated and how they are applied in the United States, right? They're single use. You apply them to the surface and they go right to the drain. So we need something that's very cost effective, that can have indirect food contact approval, right? And then, so with those two, they need to be safe if they they need to be safe to consume if they indirectly come on part of the, on the food, or if they come into food, it's not injurious to human health is probably the best way to say that. And then you just use them at high volumes and they go straight down the drain. So that's why you see the chlorines, the PAAs, and the quats used, right? And there really hasn't been, from a food contact sanitizer standpoint, there really hasn't been much innovation, just for what I just said. High volume, cheap, and then relatively safe, no human health issues if inadvertently consumed. But so that's really been our focus. But now with this disinfection, we're starting to see different options come out there where we can just apply them to plants. And the reason why those are safe to apply is because we apply them and we just rinse them from the surfaces, and it doesn't become a food safety issue. And what we really saw, and the data is out there and you can't contribute it to anything else, but wearing my cleaning and sanitation hat, I'd like to think that we had something to do with it. But relatively last year, the foodborne outbreaks reported by the USDA were the fewest that we've had in the past, I think since 2006, 2004. And I'd like to think just because we're getting cleaner plants, because we're starting to introduce disinfection steps in process, and we're also, looking at our lunch rooms, we're also looking at our locker rooms, we're also looking at our, office spaces too. Let's go ahead and disinfect those as well, right? So we're limiting cross-contamination sources. If we have persistent bacteria in the plant, we're addressing them with disinfectants, and we're just helping make plants cleaner. So really, that's where I've seen the whole industry go in the last 12 to 18 months. Is I think we're really getting cleaner. I don't want to say COVID was a good thing, but from a clean and sanitation point, I think we're really focusing on cleaning. And the reason why we have to is because we have a viral pathogen, right? And this is a different kind of pathogen that's a little bit harder to kill than bacteria. So we had to ramp up our cleaning sanitation programs to include disinfection steps. And I think it's really showing off from a micro standpoint as well, too, for everything I've seen.
Well, yeah, you're absolutely right. At the beginning of 2020, when the world kind of started to come to a grinding halt, all we heard was pretty negative news out there. And there's no question that COVID has been a devastating event worldwide. But we also have to look at some of the positives that may come out of this, if there are any, and that is we're that much more aware of general hygiene and cleanliness and sanitation. And now we're looking at the meat plants beyond just the processing area, even more so than maybe we were in the past, which is definitely going to be a good thing. So this is great. This has been fascinating. Again, I have copious amounts of notes, more than I've taken in a very long time, and I'm excited to continue to share this information with others out there and continue this conversation at another time. For those out there listening, talk to your sanitation consultant. Be that your chemical provider. If you have a food safety representative there in the plant, let's get these folks, these unsung heroes in many cases, where it's not necessarily always the most glorified job, most glamorous job, but it is an absolutely necessary job. talk about these steps, because if the food isn't safe and the environment isn't safe for the workers, then none of the production that you do have matters.
Just one last recommendation for our audience, small processors that may be wanting to just know more about sanitation, maybe some resources that you can provide, or some leads for them.
Yeah, you bet. I think RMC has a lot of good stuff available too online. If you go online, NAMI, the North American Meat Institute, I know I'm part of there. They have twice a year, they have their advanced control of Listeria monocytogenes workshop, and cleaning and sanitation is one module on it. A lot of the industry trade groups have really good information when it comes to cleaning and sanitation and recommendations. The next thing too, just to parrot what Phil said, whoever you're buying your chemicals from should know their chemicals intimately, and come up with recommendations and give you best practices on how to apply them. Now, they probably won't go as far as verifying your cleaning and sanitation program, but they should be able to provide you documentation to show theoretically it could work, which is the first process of validation. And then they can kind of guide you when you collect your data implant to show that it's actually working, which is the second part of validation. And then there's also the verification activities that are a part of that. You should be working closely with a cleaning and sanitation partner, because they should be able to help you out along, and they should help you troubleshoot too, right? Do root cause analysis of any issues that you have in your plant as well too. Different chemical, they'll have ideas about what their different chemical options are, and why they're suggesting them, because they're going to have, I didn't even go into the different ways we can build cleaners, but there's different builders you can put in depending on your water quality, the soil, or what have you, and that's why they're coming up with the choice. So work closely with them. They know their product, and they should be able to help you out. And you have to remember too that they're in several plants themselves, so I wouldn't say their knowledge is worldly, but they do have other experience they can bring to the table that you would find helpful.
Oh, nice. Thank you again for being here today. I'm sure our audience, they have any questions, we'll just send them to our email, info@meatspad.com. And if we got some questions for you, we'll make sure you can address them maybe down the road. And anything you want to add, Dr. Bass?
No, it's just been a pleasure. This is an interview that I think it was absolutely necessary, long overdue, possibly. We've put a lot of thought more into the production and quality side, which is fun and it's great and necessary. But I really hope that folks were able to glean an awful lot of information, as I have, from this interview. So thank you so much, Dr. Jeremy Adler.
No, thank you. I appreciate the opportunity. Like I said, it's tough to get this whole, well, I think we've probably been doing this about 30 minutes now talking. It's tough to get the whole picture in 30 minutes, but hopefully there's some ideas out there that I presented that make you think, and then makes you, ask more questions about your process. And that's what we're really trying to do. Because the more questions you ask, the more intimate you get with your process, and hopefully the cleaner you get. But no, I appreciate spending the time with you two. And if there's other topics in the future, more than happy to contribute as well.
Awesome. Thank you.
With that, we end this episode. Thank you a lot for listening. If you'd like to receive notifications on the new releases and the new episodes, please subscribe at www.meatspad.com. If you're a small and mid-sized meat processor and you have concerns or questions about a certain topic related to meat science and meat processing, please email us at info@meatspad.com. Thank you, and see you the next time.